Picture this. It's 1977, and scientists monitoring their equipment suddenly receive something that absolutely changes everything. We're talking about a mysterious radio signal from deep space. It lasted exactly 72 seconds, and it was so profoundly shocking that they actually dubbed it the wow signal. Welcome to this explainer on the secrets of the deep cosmos, where we are going to be searching for the unknown.
So, who or what actually sent it? Well, to this day, no one knows. And there's this terrifying, thrilling unknown behind that very question. Today, we're setting the stage for an epic spatial journey outward, straight into the void, to understand exactly what kind of universe we're shouting out into.
Okay, let's dive into this. Here is our flight itinerary for today. We're looking at our strange cosmic neighborhood, monsters of the deep, the illusion of time, where is everybody, and lastly, the invisible universe. We're taking a progressive zoom, starting right in our familiar planetary neighborhood and accelerating all the way out to the very edge of reality itself.
Let's start by grounding ourselves right here at home. In Part 1, our strange cosmic neighborhood, exploring our local solar system.
Now, you might be wondering about the heat out there. You'd naturally think the closest planet to the sun would be the absolute hottest, right? Makes sense? But actually, Venus is significantly hotter than Mercury, even though Mercury is much closer to the flames. Why? Because Venus has this incredibly thick atmosphere that acts just like a giant cosmic oven, trapping all that heat inside.
Pushing slightly further out, our neighborhood gets, well, wonderfully bizarre. First up, Mars. It's home to Olympus Mons, a volcano 3 times taller than Mount Everest. If you stood at the peak, you'd be in complete, eerie, silent isolation. Then, between Mars and Jupiter, we hit the asteroid belt. Now, sci-fi movies always show spaceships dodging tightly packed rocks, right? But space is so mind-bogglingly vast that if you stood on one of these millions of rocks, you literally couldn't even see the next one. Moving to Jupiter, our giant protector, you'll find the Great Red Spot. That is a storm that's been raging for over 300 years, and it's actually larger than the entire Earth. And Saturn? Those solid-looking rings are really just billions of tiny pieces of ice and dust. In fact, Saturn is so undense that if you somehow found a bathtub big enough, the entire planet would just float on the water like a rubber duck.
And then we reach the edge of our system at Pluto. 248. That's a big number. That is exactly how many Earth years it takes for Pluto to complete just one orbit around the Sun. The staggering takeaway here? Since humanity first discovered this little world way out at the edge of our system, it hasn't even finished a single orbit. Let's move to and see how this builds as we leave the solar system entirely for Part 2, Monsters of the Deep, the real heavyweights of the cosmos.
We're talking, of course, about black holes. These are objects so incredibly, unimaginably heavy that not even light can escape their gravitational pull. If you ever decide to visit one, I do have a rather clinical warning for you. Astrophysicists actually call what would happen to your body spaghettification. Yes, literally, the extreme gravity would pull and stretch you into a thin line. It's a funny word for a truly terrifying fate. And this isn't just happening somewhere far away either. At the center of almost every giant galaxy lies a supermassive black hole. Ours is called Sagittarius A star, and it weighs as much as 4 million of our suns.
But here's the thing. Heavyweights also give us life. When massive stars die, they don't just quietly fade out. They explode in these incredibly violent events called supernovas. What you should take away from this is actually profoundly personal. The intense heat of these explosions forged elements like gold and iron. So yes, the very iron currently flowing inside your own blood right now was forged in the violent death of a giant star.
What's left over after that massive explosion is called a neutron star, 6 billion tons. To put that into perspective, that is what a single regular-sized teaspoon of a neutron star would weigh if you brought it down here to Earth. And some of these dense leftover cores spin hundreds of times a second, shooting massive, sweeping beams of radiation across space, like cosmic lighthouses. We call those ones pulsars.
But you know, not everything stays where it was born. Consider the extremely eerie reality of cosmic wanderers. On one hand, you have rogue planets. These are entire, dark worlds that were violently ejected from their home star systems, just wandering alone through the freezing void of space forever. And on the other hand, we have rogue black holes. There are millions of these completely undetected black holes currently traveling through our very own galaxy at thousands of miles per second, just flying silently through the dark.
Now, as we look even deeper into this void, the rules of reality really begin to warp.
Welcome to Part 3, The Illusion of Time, and Einstein's mind-bending reality.
We kind of have to let this abstract weight sink in for a second. Looking into space is literally looking back in time. Why? Because light takes time to travel. Look at our nearest neighboring star, Proxima Centauri. The light we see from it takes 4 whole years just to reach Earth. So if Proxima Centauri exploded today, right this exact second, we wouldn't have a clue about it for 4 long years.
And this brilliantly illustrates Einstein's mind-bending reality of relativity. Time is absolutely not a constant, ticking clock everywhere in the universe. The faster you move through space, or the closer you are to immense gravity, the slower time moves for you compared to someone standing still. If you took a quick trip and spent just 1 hour near the gravity of a supermassive black hole, 7 entire years would have passed back on Earth. Everyone you know back home would age rapidly while you barely aged at all.
This immense, staggering scale of space and time brings us to a profound existential mystery. Part 4. Where is everybody? The Great Cosmic Silence.
We know for a fact there are billions and billions of planets out there. So, I have to present this question directly to you, a concept known as the Fermi paradox. If there is so much potential for life out there in the cosmos, where is everybody? Why is space so intensely, painfully quiet?
Well, there are a few chilling theories that attempt to answer this. The first one is called the dark forest theory. This suggests that alien civilizations absolutely do exist, but they intentionally remain completely quiet. Why would they do that? Because the universe is like a dark forest at night. If you make a sound, an aggressive predatory species will find you, and they will destroy you. Tying this back to our very first question, maybe announcing our presence by searching for the sender of that wow signal isn't such a safe idea after all.
Then there's a slightly grimmer alternative called the Great Filter. This theory posits that advanced civilizations simply always end up destroying themselves before they ever gain the technology to travel across the stars. But hey, there is a third, strangely optimistic flip side to consider. Maybe Earth is simply the very first intelligent civilization to evolve in our galaxy. Maybe we are the ancient ones, paving the way for everything else.
So, the crucial point is, everything we've just talked about, the planets, the supernovas, the black holes, the potential aliens, all of it makes up an incredibly tiny fraction of reality. Let's look at Part 5, the invisible universe, and what we actually can't see.
It is honestly shocking to realize that everything we can see in space makes up only 5% of the universe. Just 5%. The rest is completely invisible to us. About 27% is dark matter. We can't see it, we can't touch it, but its immense gravity is quite literally the only thing holding whole galaxies together. And the remaining massive 68% chunk of the pie, that's dark energy. It's this mysterious force that is physically pushing the entire universe apart, faster and faster every single second.
And because dark energy is continuously pushing everything apart, it leads to a remarkably lonely ultimate fate for our cosmos. Trillions of years from now, galaxies will be pushed so unimaginably far apart that the night sky will become completely dark. Any future civilizations born in that era won't even know that other stars existed. They'll look up and see nothing but an empty, black void. Which brings us to the absolute climax of our cosmic zoom. How vast is the space we currently inhabit? Well, the observable universe is 93 billion light-years across. Inside that incomprehensible expanse, there are more stars than there are grains of sand on all the beaches on Earth combined. Let that sink in. We started with a single 72-second signal, and we've zoomed all the way out to a universe 93 billion light-years across, leaving us staring into the dark with one final, lingering question. Are we truly alone in this massive void? Science doesn't have the answer yet. But whether the answer is yes, we are entirely alone, or no, we are not, both outcomes are equally terrifying. Our journey has just begun, so make sure you subscribe to continue exploring the deep void of the unknown with us in our next explainer.